In this video, we'll learn about the stereochemistry of cycloalkanes. Stereoisomers are molecules with the same formula and structure, the same connectivity of atoms, but a different 3D orientation of those atoms in space. These isomers cannot be interconverted without breaking bonds, but they do have the same connectivity. Cycloalkanes are not flexible like linear alkanes. There's no rotation around the carbon-carbon single bonds. And this means that substituents can be on different sides or faces of the cycloalkane, and that gives rise to stereoisomers. In this example, we'll look at two different isomers of a substituted cyclopropane. Each cyclopropane here has two methyl groups on adjacent carbons, so each of these is a 1,2 dimethyl cyclopropane. They have the same formula and the same connectivity. But in the first case, the two methyl groups are both pointing up. They're both on the top face of the ring. We call this the cis or the syn isomer. In the second case, one methyl group is pointing up while the other is pointing down. They're on different faces or different sides of the ring. We call this the trans or the anti-stereoisomer. When we name these stereoisomers, in order to distinguish between the two, we include the cis or trans designation at the beginning of the name. We'll show that here in black. Okay, and I strongly encourage you to look at this with your model kit. So you might want to pause the video and build the cis and trans stereoisomers of a substituted cycloalkane. And I'll use a disubstituted cyclobutane, not a cyclopropane because I don't want to break my model kit. But we'll look at the cyclobutane and we'll look at the cis case first. And what you see here is that both groups are pointing up. They're both on the top side or top face of the ring. And I included the hydrogens on the same carbons, so you can see they're both pointing down. They're both on the bottom face of the ring structure. And when we say the same face, that really just means we view the ring as a plane and then look at the substituents to see if they're on the same side or different sides of that plane. Okay, so again, in this case, the two methyl groups, the two red groups, are on the same face or the same side of the ring. And so this is the cis or the syn cyclobutane. Okay, now let's look at the trans or the anti-stereoisomer. Now in this case, the two substituents, indicated with red, are on opposite sides of the plane created by the ring. Okay, here you see that one of the red groups is on top of the ring and the other is pointing down, is on the bottom of the ring. So this is the trans stereoisomer. And when I build these two structures, it becomes a little bit clearer how different they really are. They have the same connectivity. They're both 1,2 dimethyl cyclobutanes, but they're not the same structure. They're not identical. I can't interconvert these two structures unless I break or form bonds, unless I move atoms. Let's pause for a concept check. Take a minute to identify each substituted cycloalkane as either cis or trans. And while you're still getting the hang of this, it's perfectly fine to go ahead and build the structures in order to help you see where these different groups are pointing. Okay, so when these structures are in 2 dimensions, the plane of the ring is essentially the plane of the paper or the plane of the screen. So in the first case, I have one methyl group pointing back behind the screen and one pointing forward in front of the screen. They're on different sides or faces of the ring, and so this is a trans cycloalkane, a trans cyclohexane. In the second case, both groups have wedges. They're both pointing forward, or both groups are positioned in front of the screen on the same face of the ring. And so this is a cis cyclopentane. In the third example, this is sort of sneaky. Remember that benzene is planar. Those carbons are sp2 hybridized, and that means that the methyl groups are in the plane of the ring. They're not pointing forward or backward, and so this is neither cis nor trans. And this last example is to remind us that cis and trans will only apply when we have groups that are pointing forward or back. Another way to say that is that we will only have cis and trans ring structures when we have sp3 hybridized carbons, or cycloalkanes. Okay, one final piece to this video on stereochemistry of cycloalkanes is how we incorporate the stereochemistry into the name of a structure. So when we have stereoisomers, or when we have a specific stereoisomer denoted in our drawing, we must indicate the stereochemistry, cis or trans, in the name. So let's apply that to the example shown here. We'll walk through our naming steps one more time. The parent here is the cyclohexane ring. Then we have two substituents or groups attached to that ring. We have a methyl group and we have an ethyl group. Our numbering in this case is determined alphabetically. The carbon bearing the ethyl fragment is carbon 1 and the methyl group is on carbon 2. This structure is a 1-ethyl, 2-methyl cyclohexane. Okay, but now let's include the stereochemistry. The methyl group is pointing up or forward, and the ethyl group is pointing down or back. So these two groups are on different sides of the ring, and the stereochemistry here is trans. So we include that in the name. The name begins with trans and then a hyphen. And the cis and trans nomenclature are included in italics, although that's hard to do when we're handwriting the names. So the complete IUPAC name of this molecule is trans 1-ethyl 2-methyl cyclohexane. Let's end this video sequence with the question we saw at the beginning, to name the organic molecule shown here. We'll start by identifying the parent, which here again is a cyclohexane. Then I like to identify and name my substituents. We have a methyl group and a chloro group. Okay, then we'll number the ring. Both possible numbering schemes will give us a total of 5, 1 plus 4. So here priority goes alphabetically, and the carbon bearing the chlorine is carbon 1. That means we have 1 chloro and a 4-methyl. Finally, let's identify the stereochemistry. The methyl group is pointing down and the chloro is pointing up. They're on different sides of the ring, so the stereochemistry is trans. So the IUPAC name for this compound is trans 1-chloro 4-methyl cyclohexane.